Hello, I hope to give you an overview of Roy Bhaskar's critical realism. Bhaskar's thought has undergone several evolutions in arguably three distinct phases, starting with what we today refer to as basic or original critical realism. It consists of his philosophy of the physical and social sciences. Then basic critical realism is followed by dialectical critical realism, and finally, it culminates in meta-reality. In this lecture, I will focus on the first incarnation of critical realism. I first met Roy Bhaskar in 2014 when he showed up as a guest lecturer in our doctoral class at the Institute of Education in London. I guess you could say that between me and critical realism, it was a case of love at first sight. But I have to add that my honeymoon with this philosophy was very much short-lived. As many of us have found out, understanding critical realism is no walk in the park. Partly because Roy Bhaskar's writing is notoriously unreadable. But I had the good fortune a couple of years later of having him as my research supervisor. And as many of his students will attest, Bhaskar is the wisest but also the gentlest and most generous of teachers. I'm calling this introduction to basic critical realism the four pillars of critical realism, because since those early years of mulling over Bhaskar's philosophy, I have come to the conclusion that critical realism has four foundational defining insights. I am hoping that this take on critical realism will help you appreciate and understand its basic ideas better. I'm going to start with Roy Bhaskar's seminal book called A Realist Theory of Science, which was published in 1975. This book spells out his ideas for a philosophy of the physical sciences, which he later extrapolated in his next book, published 4 years later, The Possibility of Critical Naturalism, where he articulates his philosophy of the social sciences. Bhaskar's philosophy of the sciences calls our attention to our underlying assumptions about the practice of science. We believe in the legitimacy of the practice of science. But what are the assumptions that are presupposed by that enterprise? The conditions that make the practice of science possible and intelligible. By assumptions, we are referring specifically to our assumptions about knowing, or our epistemology, and also our assumptions about the world that the sciences are investigating, or our ontology. According to Bhaskar, whether we know it or not, whether we like it or not, we all have an implicit epistemology and ontology anyway. These are default and often unexamined assumptions about human knowing and reality that inevitably affect our work and our thinking. So we may as well surface these assumptions and examine them so that our scholarly work will be consistent with them. For me, while Bhaskar's project was originally about the physical and later social sciences, I will argue that these assumptions about the sciences also apply to human knowing in general. The assumptions about the world that science investigates can also be extended with some qualifications to reality in general. This is one reason why I find original critical realism so powerful. Not only has it clarified for me a lot of things about the physical and the social sciences, but it has also guided me in thinking and talking more clearly about human knowing in general and other realities outside the sciences. In discussing the value of critical realism, Bhaskar has borrowed from John Locke the metaphor of the under-laborer. It's a great metaphor because, as I myself have seen in my work, critical realism, particularly its four essential insights, has helped me get more clarity and consistency in the way I think and talk about reality. As under-laborer to the work that we do, critical realism helps clear the rubbish from the discourse. Bhaskar has also occasionally described critical realism as a midwife, because the language and conceptual toolbox that it provides us can also occasionally help give birth to new perspectives, if not new insights altogether. So what are the four pillars of basic critical realism? What are the four essential insights about reality? They are intransitivity, stratification, open system, and emergence. I really wish we could do away with the jargon, but the technical terms are valuable because they are summaries of the central critical realist concepts and theories. What I will do is discuss the four insights as best as I can, as well as the critiques about ways of thinking that these four insights make us consider. Namely, and please hold your breath for another series of tongue twisters, they are relativism, positivism, determinism, and reductionism. Bhaskar begins his work by analyzing the physical sciences. If you believe in the empirical and experimental sciences, there is no denying the legitimacy of observation or sense perception and experimental activity. To analyze these two, Bhaskar asks the question, what should the world be like for science to be possible and intelligible? What is it about the world that makes observation and experimental activity possible? What are the conditions that should be present in the world for these two basic methods to make sense? The answer to this series of questions is precisely the four pillars of critical realism. For observation and experimental activity to be possible and to make sense, the world ought to be intransitive, stratified, open systemic, and emergent. Let's begin with observation and sense perception. No one's going to deny that as a scientist, it's absolutely necessary to observe, to use our sense perceptions to understand the world. What then are the conditions for the possibility of sense perception? What is it about the world that allows observation to make sense? Bhaskar discusses our very common experience of fallibility and mutability in our perception. When we use our 5 or more senses, we all experience error and changes in our perceptions. For example, somebody looks really familiar from afar, and then when you get there, oops, the person turns out to be a complete stranger. Precisely because we commit errors and precisely because our perception changes, the world that serves as a corrective to our perceptions cannot simply be our own mental construction. Reality, therefore, must be independent of the human perceiver or knower. The term that Bhaskar coins for this property of the world is intransitive. Of course, intransitive is a grammatical term that refers to verbs that do not require a direct object. But Bhaskar appropriates it to avoid all the philosophical baggage associated with a similar term like objective. So the point Roy makes is that if we believe that observation is legitimate, then the world must be intransitive. This mind independence of the world makes possible scientific criticism and scientific change and development, and also makes scientific education and training necessary. If the world were not intransitive, people could simply make up their own version of the world. There would be no point in observation. There would be no point in criticizing any perception or any theory. Without such an intransitive world, there would be no criterion for the evaluation or critique of scientific claims. There would be no such thing as scientific change or development. Finally, there would be no need for scientific education or training, because the world that science scrutinizes would be nothing more than its own creation. In short, the mind independence of the world is necessary for observation to be a legitimate method. In fact, the self-correction so essential in the empirical sciences would neither be possible or make sense if the objects of their study were merely dependent on their very processes. This first pillar of critical realism is the assertion that the world that science investigates, and in fact that we strive to know, is intransitive, meaning it is relatively autonomous of scientists and knowers in general. It's actually been said that the biggest celebrations in NASA occur when the scientists discover that they have been wrong. That's proof that the universe is intransitive, because you got corrected by the universe. But the flip side of that is that the very enterprise of science is transitive. While the world that science strives to understand is nowhere independent, its theories, concepts, its methodologies, and very paradigms are all nowhere dependent. Science, like all human knowledge, is socially produced. Individual scientists never work in a vacuum. They always work with what is already there. Every scientist inherits a body of knowledge already there, and the scientist builds on it, correcting or confirming existing theories. So in the critical realist view, knowledge has two distinct dimensions: the intransitive dimension, the nowhere independent world that we are trying to understand, and the transitive dimension, the nowhere dependent processes and products of knowledge. It is very important to preserve the distinction between these two dimensions, to resist the temptation of conflating them when we reduce all of reality to only what we know of it. This tendency is called epistemic fallacy, when we mistakenly consider ontology as identical to epistemology. In this diagram, the blue rectangle stands for reality or ontology, while the smaller red square represents our knowledge of reality or epistemology, which is of course limited. Epistemic fallacy is basically the conflation of the two, so that ontology is reduced to and is regarded as equivalent to epistemology. We are guilty of committing epistemic fallacy more often than we think. For example, in our relationships, we have a natural tendency to reduce the reality and mystery of the other person into our knowledge or understanding of that person. As a result, because of epistemic fallacy, relationships get strained or they fall apart. Who would have thought? This essential distinction between the intransitive and transitive dimensions of science is captured in the three essential concepts of critical realist epistemology that together constitutes what Bhaskar calls the holy trinity of critical realism. The first of these three concepts is judgmental rationality, which is a commitment to evaluating different and even opposing claims about reality. For example, is the earth flat or is it a sphere? According to judgmental rationality, it is possible to determine, as best as we can, even if only for now, which of these two alternative theories is more sound, given all available evidence to date and all the authoritative interpretations of these evidences so far. What makes it possible to make such judgments is precisely the intransitivity of the world. Because the world is relatively autonomous of us knowers, there's an actual criterion on which we can base our judgments. This belief in an intransitive world that makes judgmental rationality possible is the second element of the holy trinity of critical realism, and it is called ontological realism. The third and final element is called epistemic relativism, and it has to do with human knowledge, which we have already characterized as transitive. Any theory, and in fact any knowledge claim or account of the world, being nowhere dependent, is necessarily historically and culturally bound. And for that reason, all human knowledge is perspectival, limited, and necessarily fallible. Precisely because of epistemic relativism, that is the plurality of claims about reality, all of them limited and relative, it is necessary to evaluate them and to determine to the best of our ability which claim is the most sound. In short, while epistemic relativism makes the exercise of judgmental rationality necessary, it is ontological realism that makes it possible. The holy trinity of critical realism is a critique of relativism, the postmodernist tendency to hold that all views are equally correct. This form of relativism, the hesitation or refusal to make a judgment, is the very opposite of judgmental rationality, which is a commitment precisely to evaluating claims and assertions about reality. In fact, Bhaskar calls it judgmental relativism to distinguish it from epistemic relativism. Epistemic relativism accepts that our knowledge is relative, but ontological realism denies that reality itself is relative. In critical realism, therefore, relativism is restricted only to knowledge and is not allowed to characterize reality itself. For critical realism, knowledge is therefore a judgment. Compare that to the relativist conception of knowledge as mere opinion. While we are expected to respect everyone's opinion, judgments are meant to be exercised and evaluated. Knowledge as judgment captures both the intransitive nature of the world and the transitive nature of human knowing. In summary, the first conclusion of critical realism is that observation and sense perception would not be possible, nor would they make sense if the world were only a mental construction that is dependent on the knower. The world must therefore be intransitive. This is the first pillar of critical realism, its first fundamental insight about the world. The second critical realist pillar is called stratification. Let's focus on another familiar experience as far as perception is concerned. It's finitude. Our perceptions are necessarily limited. We have not perceived nor can we perceive everything. Bhaskar accounts for our unquestionably finite perception by asserting that reality, which we have just demonstrated as intransitive, is also stratified. By stratified, Bhaskar means that the world has more than one domain. Reality does not just consist of our experiences, which comprise the domain of the empirical. When we think about it, there are many events in the world which have not been discovered or experienced by humanity. So there must be a domain beyond the empirical one. This larger domain, which we call the domain of the actual, includes both our experiences and events that have not been or will never be experienced. If we conflate these two domains, as we are often tempted to do, we are committing epistemic fallacy, because we are once again reducing reality only to our experience of it. But some events have not been experienced or known, and possibly others, by their very nature, can in principle never be experienced or known. One example that comes to mind here is the black hole. Strictly speaking, the black hole itself cannot be experienced, only its effects. Recent photographs of the black hole are not photographs of the black hole itself, but only of its effects. In short, just because we haven't experienced something does not mean that it is not real. There may be events in the universe that nobody has experienced or no one will ever experience, but they are no less real. Just to clarify, when we refer to the empirical domain of experiences, We are not talking about personal experiences. Rather, we're referring to the collective experience of humanity in all of its history. So I may not have personally experienced the Holocaust, but millions have, and many documents attest to it. So this historical event clearly belongs to the empirical domain. By stressing that all our perceptions and observations are limited, Bhaskar reaches the conclusion that there are at least two domains in reality. The first is a domain of the empirical, the set of all humanity's experiences, represented here by the white circle. Then we have the bigger gray circle, which stands for the domain of the actual, which includes the empirical, but also events that have not been experienced. Stratification, therefore, means that there are events beyond our perception, beyond the collective experiences of humanity. Perception as a scientific method makes sense, and it is valuable precisely because we do not have or have not perceived everything. But this diagram of two circles, inferred from Bhaskar's analysis of observation, is still an incomplete picture of the stratified world. A third domain of reality emerges from Bhaskar's analysis of experimental activity. In the same way that critical realism identified intransitivity and stratification as necessary conditions for observation or sense perception to be possible and intelligible, it is through an analysis of experimental activity that Bhaskar argues for a third domain of reality, the domain of the real. To analyze experimental activity, we pose the same questions. What about the world makes it possible? What characteristic of reality allows this method to make sense? For Bhaskar, experimental activity has two defining components: experimental production and experimental control. Let us first focus on experimental production, because it is what will help us complete our sketch of the stratified world. We will reserve our discussion of experimental control when we introduce the third pillar of critical realism. We discover causality through a regular sequence of events. So if event A regularly leads to event B, then it is possible that there is a causal law. I say possible because, as we have been told too often, it is not the case that a correlation between two such events will guarantee that there is actually causality. What a scientist does in an experiment is to produce sequences of events in a laboratory in order to discover causal laws. For example, if I add salt to water, event A, the boiling temperature of the water increases, event B. Now think about it. This sequence of events itself cannot be the causal law that the scientist is trying to discover because he or she already knows it. If that were the case, then there would be nothing to discover. Adding salt to water increases its boiling temperature doesn't quite sound like a scientific explanation. The causal law will have to do with the properties of the water molecules and their need for more energy to overcome the surrounding vapor pressure to transition into gas. By the same logic, event A, the addition of salt to water, cannot be considered the cause for event B, the rise in the water's boiling temperature. The cause must be something distinctive from the addition of salt. Bhaskar's conclusion is that there must be a third domain of reality, the red circle, which he has named the domain of the real. The domain of the real includes the empirical and actual domains. Both experienced and unexperienced events are real, but they do not exhaust reality. Reality also includes causal powers that are neither actual nor empirical. It is these causal powers, the way they operate, and the conditions that trigger them, that scientists are seeking to uncover in experimental activity. In summary, critical realism teaches us to make two important distinctions. First, the distinction between causal laws and the regular patterns of events. The patterns of events that scientists replicate in the laboratory are not the causal laws that they are trying to discover. This is an important distinction because this has been the prevalent definition of causality that started with David Hume, for whom causality is equivalent to the constant conjunction of events. So for empirical realists like Hume and many who followed him, event A is the actual cause, and event B is the effect. And the causal law is simply if event A, then event B. But that kind of causal law does not help us understand anything. Second, the distinction between causes and conditions. In our diagram, event A is not the cause, but simply the condition that activates the underlying cause, cause X. Going back to our example, adding salt to water is not the cause, but the condition that activates the underlying molecular properties, so we end up with the effect of event B. The boiling temperature is higher when we add salt to the water, tells us what happens, but it does not give us an understanding of why the boiling temperature of water rises. Compare that to the ions from the salt interfere with the formation of vapor bubbles necessary for boiling. Doesn't the second explanation sound more like a proper scientific causal law that actually helps us better understand the phenomenon? In summary, both Bhaskar's analyses of observation and experimental activity have led us to the conclusion that the world must be stratified with three domains: the domain of the empirical, experiences, the domain of the actual, events, and the domain of the real, causal powers. Experimental activity makes sense only if the causal laws were distinct from the sequence of events that scientists create in the laboratory. Hence, causes must belong to a non-empirical domain, the domain of the real, and causes must be distinct from the empirical conditions that trigger their operation. The way of thinking that stratification critiques is positivism, which, when you think about it, is the conflation of all three domains to the domain of the empirical. For a positivist, the only way they would ascribe reality to something is that it should be part of our experience. In answering the question, what is real, they would use only the perceptual criterion. In short, to see is to believe. Something is real if and only if I perceived it or experienced it. In short, it should belong to the empirical domain. By reducing all three domains to only the empirical, we are committing the positivist fallacy of the empirical world, the mistaken claim that all of reality consists exclusively of what has been experienced. But what happens to our sense of reality? If we fall for this temptation, we end up impoverishing our sense of reality. The critical realist challenge is for us to stretch our horizon of reality beyond the empirical tip of the iceberg of reality, to toss the perceptual criterion for reality out the window and adopt the more expansive critical realist criterion for reality, which is the causal criterion. To the question, what is real? The critical realist response is not just what we have experienced or perceived, but whatever is causally efficacious, whatever can yield an outcome, whatever can make a difference, whether perceived or not. In short, not just one, but all three domains of reality. The concept of stratification is particularly valuable for those of us who are engaged in investigating social phenomena. It makes us question ourselves whether there's something more that we are neglecting or missing in our research. It is a question that scholars constantly need to ask themselves, a disposition of openness to possibilities that we always need to assume. The black hole, for example, was a theory that stemmed from an anomaly in Einstein's calculations. If scientists had dismissed this possibility, we would never have been able to verify its existence when the technology eventually enabled us to do so. Bhaskar infers the third central insight of critical realism from his analysis of experimental control. We live in a world of constant flux, a world often not under our control, where chance and coincidence occur quite frequently. The world is, to use the critical realist term, an open system. Unlike the closed system of the laboratory, in the outside world, a multiplicity of causes are normally at work, interacting with one another to co-determine outcomes. Sometimes there is no outcome because different causal powers cancel each other out. It is this open feature of the world, beyond the confines of the laboratory, that makes it necessary for scientists to close the system by making sure to control all variables other than the hypothesized cause, and to keep them from interfering with the experiment. In short, experimental control is about designing the laboratory conditions so they are free from extraneous variables. Because the world is an open system, it is only through such experimental closure that causal laws become empirically accessible. If we want to discover causal laws in the world at large, passive observation without intervention is unfortunately not enough. For the physical sciences, this intervention entails closing the system in the laboratory in order to produce a desired sequence of events and in the process uncover the causal laws. In the closed system of the laboratory, the scientists make sure that event A leads to event B as a result of cause X by preventing causes Y and Z from interfering as they might normally do in the open system. In the open system, however, because we are not intervening, cause X may still be causing event A, but it does not lead to event B, but to some other outcome, event C, because of the interference of causes Y and Z. What is most significant about this insight into the world as an open system is its redefinition of causality. The traditional definition promoted by David Hume and other empirical realists is positivist and successionist, defining it as the constant conjunction of events. But it really is no more than correlation, because event A is identified as the cause of event B. Critical realism rejects this positivist and empirical realist definition. For critical realism, causality is not necessary correlation. It is not empirical determination. Rather, causality is necessity without determination. It means causal laws are about tendencies of acting in the open system which may or may not be realized in any sort of outcome. There are three important messages here. First, let us not oversimplify causality. Most phenomena in the open system, especially social phenomena, are multi-causal, the outcome of several interacting causal powers. Scientific explanations, therefore, need to take into consideration not just one, but all other significant causal powers interacting with the primary cause that you are investigating. Secondly, let us not overread for causality by mistaking correlation for causality. At best, the constant conjunction of events is a possible indicator of a causal relationship, but is by no means a guarantee that there is indeed a causal law. In the same vein, let us not mistake the condition needed for the cause to operate to be itself the cause. Just because there is an outcome does not mean that there is a cause. It may be mere coincidence, the result of the interaction of different forces in the open system. In the same vein, just because there is no outcome does not mean that there is no cause. The effect of the cause may simply have been contravened by other causes operating in the world. Finally, let us not overreach for causality. Just because there is a cause doesn't mean that there will be an outcome. Causal laws do not determine events. They only define the possibilities and limits of acting in the open system. As Anscombe puts it, outside the domain of closure, laws are like the rules of chess or any sport for that matter. The play is seldom determined, but no one breaks the rules. Just because there's gravity, for example, does not mean we're always going to fall. No one is breaking the law, but we could defy gravity via other causes like our muscles or airplanes, for example. Causal laws define the possibilities and limits of acting in the world, but they do not dictate their outcomes. The concept of the open system constitutes critical realism's critique of determinism. Causal powers may be operating, but they do not guarantee that their operation will actualize into an event because of the other causal powers that may get in the way. By virtue of the open system, prediction is not reliable beyond the confines of the laboratory, especially in the social sciences. In summary, the third pillar of critical realism is the recognition that the world, including and especially the social world, is an open system. And we know this because experimental activity would not be necessary if there were universal closure. We would not need to conduct experiments if causal laws were self-evident and causal powers did not interfere with one another. The last of the four pillars of critical realism is emergence. If the open system tells us that there are different causal powers actively operating in the world at large, emergence qualifies that statement by saying that there are different types or levels of causal powers. Let's begin by defining emergence. Emergence happens when a new entity turns up because more basic entities have combined in a specific way. While dependent on them, this new entity possesses properties that are qualitatively different from its components and are not reducible to them. I like using three examples to illustrate what emergence means. The first and simplest example is water. You don't have water unless you have two molecules of hydrogen and one molecule of oxygen. But the water that emerges from this special combination has properties and causal powers that are qualitatively different from those of hydrogen and oxygen. If you want to investigate water, it would not be sufficient only to study hydrogen and oxygen. It is not the case that water is nothing but hydrogen and oxygen. There is something substantially different once we get water. While water is dependent and rooted in hydrogen and oxygen, water is emergent from those molecules and irreducible to them. A second example, human consciousness. We need a brain for consciousness to emerge, a specific combination of matter and neural connections. But you can't say that consciousness is nothing but the brain. Something else is already going on once we get consciousness. Consciousness has causal powers that the physical brain may not have. Consciousness is dependent and rooted in the physical brain, yes, but it is by no means reducible to it. Our final example of emergence is society. We can't say that society is nothing but a bunch of individuals. Those very individuals need to be related in particular ways with their roles and practices for society to emerge. But the social structures that emerge have properties and causal powers all their own. Social structures are rooted in people, yes, because you can't have society without people, but society cannot be just reduced to people. Your understanding of society is not adequate if you only investigate the members of society. So when we talk about different causal powers, we can visualize them as some kind of hierarchy, from the more basic to the more complex, as shown in this diagram. This diagram illustrates but does not exhaust the different levels of causal powers. You have the physical and the chemical at the very base, followed by the biological, the psychological, and the social. Most phenomena in the open system are complex, with multiple causes. So an adequate scientific explanation cannot be reductionist, but it ought to take a phenomenon into account in all its complexity. If it's a social phenomenon, apart from the social structural causes, how significant are the psychological, biological, and physical and chemical causal powers? In summary, each of the levels is irreducible. Each level is causal. And using the causal criterion of reality, we have to conclude that each level is real in its own right. Our task as investigators is precisely to determine which levels are significant in our study and to make sense of how these different levels interact to account for the phenomenon. The concept of emergence has three important implications. First, it refutes the fallacious thinking of reductionism, or what we can colloquially call the nothing but mentality. To be reductionist is to believe that water is nothing but hydrogen and oxygen, human consciousness is nothing but the physical brain, and the society is nothing but a bunch of people. It reduces the higher complex causal powers into their components, and it claims that you can understand and explain any phenomenon by exclusively focusing on the lower order causes. It's sort of an extreme form of the theory of everything. Emergence reminds us that we need to study water itself, consciousness itself, and society itself, and not just their components. The higher order causes have emergent and irreducible properties that cannot be explained away by descriptions and explanations of the more basic causes. Secondly, emergence offers the best argument for interdisciplinarity. Think about it. It is the hierarchy of causal powers in the intransitive world that creates the need for a transitive hierarchy of autonomous sciences. To study human consciousness, we do need physics, chemistry, and biology, but we also need psychology. To understand society, psychology won't be enough. We also need the social sciences. Let's take the example of clinical depression. It is a multi-causal phenomenon, the result of the interaction not only of several causes, but several types of causes. A dysfunctional family and the absence of peer support are examples of significant social causes. A genetic tendency for depression is a relevant physical and chemical cause. The individual's willpower and inner resources would also be a significant psychological cause. Using the critical realist definition of causality, each of these, all things equal, create tendencies, either facilitating or impeding depression, as illustrated by the broken arrows in our diagram. But at the end of the day, it's the interaction of these causes that will determine whether or not depression will actually happen. Given such a case, the job of the scientist is precisely to identify which of these possible causes are significant in this particular case, and just as importantly, to account for their interaction, how the physical and chemical interact with the psychological and the social, leading to the onset of depression or not. Finally, this insight into emergence also strengthens the case for critical realism's opposition to determinism. We have seen that because of the interaction of different causal powers in the open system, we cannot assume that causes determine outcomes automatically, because they will not always inevitably lead to their expected effects. Emergence adds another reason against determinism. Higher order causes are not completely determined by the lower order causes. Yes, they remain subject to the laws governing their more basic components. For example, consciousness will surely be affected by the health of one's physical brain and body, but not completely. In fact, the higher order causes are capable of acting back on the lower order causes because they have, to some extent, causal power over them too. In short, not only is there upward causality, where the lower order causes condition the higher order ones, but also there is downward causality to some extent, where the higher order causes enable or constrain the operations of lower order causes. Let's go back to that example of clinical depression. Just because I have a depression gene doesn't mean that I'm condemned to actually getting depressed. Note that my physiological tendency towards depression does not belong to the domain of the empirical and actual for now. But the gene is no less real, just not activated. Social causes such as stress from a dysfunctional family, coupled with the absence of peer support, may interact with and reinforce my physiological tendency for depression. However, if I fortunately have adequate emotional resources, I could counteract these tendencies through my willpower. In this case, human agency, which by the way, critical realism insists is a legitimate psychological causal power, has constrained the operations of the physical, biological, and social causes. As illustrated in this diagram, human agency will always remain subject to physical, chemical, biological, and social causal powers, but it is not determined by it. In short, this is good news. We are by no means slaves or victims to these forces. We can act back on them to the extent that we are able to manage these other causes. When you think about it, isn't this what human freedom is about? What's wonderful about critical realism is that it does not deny human freedom, nor does it treat it as an anomaly or exception in the world. Rather, it acknowledges human agency as a legitimate causal power and gives it a space among other causal powers in the open system. We are by no means at the mercy of all these other forces. Human agency is causally efficacious, and therefore it is real. Albeit, like all other causal powers in the open system, it is limited by their operations. In summary, critical realism has four foundational insights which I consider its four pillars. Intransitivity, which critiques relativism. Stratification, which counters positivism. Open system, which refutes determinism. And emergence, which debunks reductionism. These four concepts can help clear the ground for our thinking and talking and guide us in our investigations.